challenges that we're having with the acoustic telemetry information is that once a tagged fish has been eaten by a predator and the predator swims by your receiver, then you're assuming that that is from a live fish. Now, in the VAMP 2010 report, we recognize this limitation, and so the way we approached it was we estimated survival 2 ways, one with all of the detections, and then with what we felt like was a conservative approach of taking detections out from what we thought were from tags that were in predators now. And so reported both estimates, but giving our best estimate as the 5% survival.
I assume those tags don't stay in a predator forever, or do they accumulate?
Well, that is a good question too. How long do they stay in the predator? When did they get eaten? How quickly did they pass the receiver? Those are some challenges that we're having that they don't necessarily have on the Columbia River, where they've used this technology a lot because they don't have the migratory predators as we do.
Thank you.
So this graph is just simulated information, just showing how delta survival influences adult recruitment, giving an average estimate of survival to adulthood. So on the X graph, I've got X-axis. I have the number of Mossdale smolts, estimating the number of fish that are coming in into the delta from Mossdale and the South Delta, and what that range has generally been from 60,000 to 4 million, and then showed at the different levels of survival of 5%, 20%, 50%, and 80%, how that affects the resulting adult recruitment. And you can see that if you have only 5% survival, you're not going to get much benefit no matter what you have coming into the delta from upstream. So some of the simulations we've done also in some of our previous submittals, we were using average estimates of survival in different phases of the life history, and it appeared that a rate of 50% survival through the delta could allow you to meet the doubling goal in a little less than 30 years. Okay, so this graph was just going to make a plug for the importance of continued monitoring of survival, both upstream and in the delta. Right now, we don't really have any consistent survival monitoring occurring in the Sacramento River for smolts that are entering the delta from the Sacramento River and migrating through the delta. The VAMP study was very good, that it provided the funding for a long-term survival monitoring program, so we at least we could assess what survival was. Right now, that's no longer occurring. Once VAMP sunsetted, the monitoring was not continued. We've been trying to piecemeal it to try to continue it, but it's a need that has not been fully addressed. And I guess secondarily is that although we were able to estimate survival for the VAMP study, there was certain aspects of it that we weren't able to complete in the 12 years that we had the VAMP study.
Pat, on the previous panel, one of the speakers, I believe from Fish and Game, but I'm not positive, talked about how hatchery fish were humanized, I think was the phrase that was used, but basically they were raised in an environment where they weren't quite as viable going out. But if I understand this, the only metric that we have for determining out migration is hatchery fish, because they're the only ones you can get your hands on and put a wire into. So we're assuming that there's no difference between the viability of an out-migrating wild fish as opposed to an out-migrating hatchery fish?
I don't know that we're assuming that the survival is the same, but from a
You put a factor in it?
I'm not going to put a factor in it. There may be others that would, but I don't feel comfortable doing that. But the point is, I guess from a relative standpoint, if you continue to use hatchery fish and you're comparing on a relative sense, then it should still give you some framework of assessing when there's good conditions relative to bad conditions on a relative.
I believe in the McCullum River they were doing just that, and I don't know, I think Fish and Game and Fish and Wildlife were involved, where they were essentially not hand feeding the fish. They were letting them develop natural tendencies. They were going to be marking them. As last year, I don't remember exactly what the time frame was, but that should answer that question, that study.
Well, yes and no. Yes, we what you're speaking to is adding behavioral diversity to hatchery raised fish, changing complexities of how they're raised. I think
it was a pretty fancy stick they had laying in the tank, I'll have to admit.
Yeah, I think the question that the chairman brought up is about on the studies about using tagged fish from hatcheries. Would you assume you'd get the same result from wild spawned fish?
That's correct.
You would not assume you get the same, but there's two reasons you use the tagged fish. One, you need numbers. You need numbers of animals because you have to track them and you have to catch them. Second, you're dealing with stocks of fish which are at risk. So the problem about, no, we don't make the assumption that the survival or the behavior would be the same, but you're running a living experiment, and there are no assumptions that the hatchery fish would behave the same as wild fish. So, but they're what we have to literally experiment with.
No, please understand, Kevin, I wasn't questioning the logic that goes into
Right.
doing this monitoring. I was trying to figure out how you did factor, and I think I'm hearing you
Right.
say it's
There-
impossible to really tell, but at least you have a tool.
There are other tools that people are using for wild fish. They're looking at elemental components of their scales. So as they are able to collect scales from wild fish that have moved through the system, analyzing them, specifically strontium. So there are other tools, but the other part is that you need a lot of these animals to be able to release, and the hatcheries allow you to do that. And then for each experiment, you can give them a unique code, so you know what code they're associated with.
Sorry to interrupt you, Pat.
Just want to add that Phil Stanstrom has done some acoustically tagging of wild steelhead and compared that to the hatchery steelhead. And he does have that written up, I believe. And there was some differences. I don't recall exactly what they were. Actually, I recall more of a timing difference. So some of that information is available. The point I was trying to make with this slide here is that the VAMP tests that we had was in the study design was intended to evaluate the role of exports using two different conditions at flows at 7,000 CFS. We wanted to get export of 1,500 exports and one of 3,000 exports to compare and contrast what the role of exports was at any particular one flow. But we were unable to get those two conditions during the 12-year experiment. So what I have on the graph shows you how flow of Vernalis varied with exports during the studies that we conducted, and pretty much they're correlated that as flows increased, exports increased, so we weren't really able to identify the independent role or separate role of exports from flow from these studies. So in addition, I just wanted to reemphasize and support what Fish and Game has talked about relative to the increasing the frequency and duration of the Delta cross-channel gate closures. I believe NIMS will also talk about that to be consistent with the 2009 biological opinion. And then I just wanted to remind the board and the board staff that we had brought up in our previous submittals that it appears that the proportion of fish going into the interior delta through Georgiana Slough is also a function of flow, and low flows that potentially you're getting more fish going into Georgiana Slough because they're coming back into Georgiana Slough on a flood tide, even when the Delta cross channel gates are closed. So just want to remind you of that again. That's one area to consider as you're revising the 2006 Bay Delta Plan. So one of the other questions that the board asked in the notice was what to do about scientific uncertainty and changing circumstances. What we suggest here is, as everyone else has also, with an adaptive management plan, but we would like them to like you to consider being more protective while you develop your adaptive management plan. And just a few comments on a note of what we have talked about in our previous submittals. Although there is uncertainty, there is evidence that increased flows will benefit native fishes, including salmonids. And there's also some evidence that suggests that exports will decrease salmon survival for fish that enter the interior delta. And this is a relationship from publication Newman and Brandis in 2010, shows the relationship between Georgiana Slough survival of marked fish relative to fish released at ride, and how that survival changes at different export levels. And as exports increase, survival goes down. There is uncertainty with this relationship. It's a lot of noise. There's a low sample size. Although Brad said we've been studying it for a long time, this is, I think, 15 data points. I think it's like 13 years worth of data, so it takes a long time to measure these things with the precision that you really need. The power analysis that we did, this is with using Codawar tags fish. The analysis that Ken did in this paper suggested that we needed 100 replicates to get the precision to be much better than it is here. So we recognize there's a lot of noise relative to the signal, but we were able to detect a relationship. And then the key to this particular relationship is what proportion of fish are actually entering the interior delta that are being exposed to this export effect. And Russ Perry, we mentioned in some of our previous medals, has done a PhD dissertation, and he's identified that the proportion entering the interior delta is a function of flow and also of the tidal phase. As I mentioned previously, if we can move that tidal phase far enough downstream so it's not in the vicinity of Georgiana Slough, then the fish are not evicted back upstream on a flood tide to enter Georgiana Slough, even when the cross-channel gates are closed. Just a few comments on adaptive management. We believe there's some specific needs relative to an adaptive management plan, such as specific biological and physical indicators that can be tracked to identify progress, and that there is a range of flow alternatives be identified up front. So if you need to adaptively manage, you'll know up front where you're going to be adaptively managing to change. How are you going to change your management? And then we also in our submittal provided some information on some technical and application guides that the Department of Interior have recently put out that might be helpful to the board in implementing adaptive management. So lastly, just a few comments and from previous submittals that we have made, indicating that flow is one of the most important components of ecosystem function. Changes in delta flows and flow variability have contributed to declines of multiple native species, including salmonids. We feel delta inflow and outflow are important for salmon migration cues and juvenile survival and abundance. There's multiple mechanisms hypothesized for this increased survival at higher flows, things such as reduced water temperature, lower percentage of water diverted, reduced entrainment, lower predation and disease, elimination of reverse flows, and increased floodplain habitat. Couple parting thoughts from our previous submittals. The board should consider flow objectives based on a similar percent of unimpaired flow from each of the San Joaquin tributaries to meet the Vernalis objective, and increase flows that mimic the general seasonality, variability, magnitude, and duration of the natural hydrograph will benefit native fisheries, including salmonids. Thank you.
Good afternoon, board members. This afternoon, I'm going to focus on these following 5 key points. I'll mention some additional tidbits of information on the winter run status. I'll talk about what NMFS's 2009 biological opinion on long-term operations of the Central Valley Project and State Water Project is and what it is not. Have a suggestion on modeling for outflows, and as Pat and other panelists mentioned, the benefit of increased flows on native fish, including salmonids, and then some additional information that's up and coming. So you guys have seen this graph a couple times earlier. There's some additional information that I wanted to highlight. In 2011, there were approximately 824 returning adults into the system, and not only is that just a low number, but it's the lowest since 1996. So that's something to consider over the last 18 years or so, how the system has been managed in the main stem Sacramento River in the Delta to cause this decline. And also, one thing that we look at is the cohort replacement rate. That's the growth rate of individual cohorts of any salmonid species, and over the last 6 years, there's been a cohort replacement rate of less than 1, which means the cohort, the species, is not replacing itself over the last 6 years. Additionally, including numbers, we look at other things. I mentioned growth rate. We also look at spatial structure. I think we all know that winter run, there's only one population in the main stem Sacramento River, so they're really at risk in addition to its endangered status under the federal ESA, and also genetic diversity, how much influence the hatchery component plays into the population, and life history diversity. We touched on that a little bit about how we don't want to put all the eggs in the same basket as far as flows to get the smolts out all at once. We want to spread it out to utilize the habitat and timing of winter run going out into the ocean and use in the Delta.
Excuse me. Does this graph indicate all winter run adults, or does it just deal with wild?
It's both, I think.
Okay.
So the 824 that I mentioned includes the hatchery component. Well, I should say the adults that returned and have the adipose clip. So the NIMS 2009 opinion, what it is and what it is not. The scope of the BIOP, I wanted to emphasize that the federal action that we consulted on is long-term operations of the Central Valley Project and State Water Project, so it's limited to the CVP and SWP controlled streams in the Sacramento and San Joaquin River systems, including operations in the Delta and the export facilities. What it does not include are other federal and non-federal actions that could affect all of the listed species survival and recovery, and that is dealt with either in different sections of the Endangered Species Act or other Section 7 consultations. It's also focused on listed species. Here we have winter run, spring run, and steelhead. It does not include fall run and late fall run, which are obviously part of the system and that we're concerned about. I mentioned other areas that this biological opinion does not include. For example, the tributaries where the bulk of the spring run are Butte Creek, Mill Creek, Deer Creek, and other tributaries. We do have NIMS involvement in some of the other actions that I mentioned, the federal ones, for example, FERC, Federal Energy Regulatory Commission relicensing efforts. we're aware of ocean fisheries. We have involvement, and there's consultation through suggested quotas, for example, through PFMC each year for ocean harvest. We mentioned the NIMS biological opinion, but the cover letter that transmits the biological opinion also transmits an essential fish habitat component. So we have essential fish habitat conservation recommendations that include habitat needs and recommendations for fall run and late fall run, in addition to winter and spring run. And these recommendations are just that, they're recommendations and discretionary. So additional areas that the State Water Board may have jurisdiction include the other tributaries that are outside the influence of the NIMS 2009 biological opinion, also the Sacramento River tributaries, and also includes consideration of fall and late fall run as a whole ecosystem and not just focused on listed species. So some new information since 2009, since our biological opinion. One of the requirements that we have in the biological opinion is an annual review that shall be conducted by November 30th, and that's reclamation and NIMS in conjunction with now the Delta Science Program, and that's to review how we did. Take a look, basically a report card of all the actions, and to the extent that we can, the biological responses of the fish and the habitat to these, as I understand, 72 actions within our RPA. We did that in 2010, 2011, and we have one coming up October 31st and November 1st of this year. As a result of some of the recommendations and also some of the, I guess, kinks in the system, things that didn't work out as well as we thought, or in the case of adaptive management of things that we would want to change, and I would emphasize that they're minor adjustments to implementing the reasonable and prudent alternative actions. We did make amendments to the 2009 biological opinion reflected in this 2011 RPA amendments document, and we issued that on April 7th, 2011. In the interest of staying out of court and also adaptive management, we entered into a joint stipulation that included a sentinel steelhead study that Brad mentioned, staying up to midnight to work on a report. I stay up to midnight working on the annual review for this year. So I guess we're even, but this is an effort to all come at the table. Kenny Rose mentioned the people aspect of this whole system. So come at the table and let's see what the problems are and how can we move ahead together. So we had the Sentinel Steelhead study, a draft document, and with an initial data analysis is forthcoming, I understand, October 4th. So we'll have a better idea of exactly what we did and some of the results, hopefully, that'll help inform subsequent management in the Delta. We also had as additional information a National Academy of Sciences review of our 2009 biological opinion, and it also included the 2008, December 15th, 2008 biological opinion from the Fish and Wildlife Service on Delta smelt. And these are a couple of the quotes. I'm not going to read them. I'll give you a few seconds to read these quotes. So in general, the two words that I remember as a conclusion from the National Academy of Sciences panel was that the reasonable and prudent alternative, well, the jeopardy determination and the RPA were scientifically justified, of course, with recommendations on how to improve certain actions. So it's not all about the Delta. Water flows down into the Delta. So we're concerned about cold water pool management also. There's concepts out there about how we need to restore the natural flow regime. And I would suggest not doing that because of the rim dams. If we restore natural flow regime, which is lower flows in the summer and higher flows, higher flows in the winter, that creates problems, for example, in winter run where they spawn in the summer. And if we have low flows might equal higher temperatures, and that's not good for winter run spawning, incubation, and rearing. So I would suggest that the natural flow regime not be focused, but the functions and ecosystem services of natural flow regime. So provide, for example, for winter run, the cold water that they need, adequate flows, water quantity and quality for egg incubation in the habitat that we talked about that's not available right now in the Sacramento River with basically a canal, how it's all levied downstream to provide the habitat that they need, going down into the delta and out, eventually out the Golden Gate Bridge. What we do need, though, is to carefully control the reservoir releases for the benefit of these listed species for their survival and ultimate recovery. The system, and we don't want to pit things like delta outflow and the focus on delta species. For our species, they pass through the delta, they utilize the delta, both upstream and downstream. So I would suggest that the whole ecosystem, and I'm sure we all know this, but the whole ecosystem is connected both upstream and downstream. Whatever we do upstream as far as delta releases or reservoir releases affect the delta, and it affects reservoir storage. It's connected across seasons, whether we're talking about water year types or warm water, cold water pool, everything's affected. And we need to take all of that in consideration when we're talking about managing the whole ecosystem. So other panelists, and I also mentioned that we have listed species in the system. We have an endangered species, winter run. We have some threatened species and some that we're just concerned with that are not listed. So I would suggest that what do we do in the future? We should use the precautionary approach. There's certain things, for example, let's try this, but we're concerned about trying, whatever this is, we're concerned that it might result in an, oh no, this did have serious impacts on, for example, winter run. So what are we going to do about that? We can't go back in time and reverse this. So the precautionary approach would add a little layer of protection, I guess, as far as studies and as far as management implications of what we're trying to study. And that goes along with the monitoring and adaptive management process. If we apply the precautionary approach, as with the 2011 adjustments to the 2009 biological opinion, we could always adaptively manage and adjust some of the operations or some of the things that we've learned through these monitoring protocols. And with all of that, intensive monitoring, changes in technology, as we talked about earlier about acoustic tag versus coated wire tags, that would require a substantial commitment of resources, and that's both funding the monitoring and also the staffing. So here's some of the forthcoming information. I mentioned the annual reviews and the NAS review that came out in 2010. NIMS anticipates a final recovery plan. There's a draft that went out for co-manager review, and we've been coordinating closely with the resource agencies and others, and incorporating comments and meeting with stakeholders. We anticipate this coming out. I'm not exactly sure when, but it says here winter of 2012, 2013. We have a life cycle model that our science center is working on. There's also a paper on winter run. Pat mentioned she had a graph up there on the timing of winter run coming down in the Sacramento River and the timing of winter run leaving Chips Island. There's a gap of about 3 months. So where are they in the Delta? Are they in the Delta? Where are they and what are they doing? So we have a paper that's in review right now that summarizes some of the previous studies and indications of those questions. Where are they and what are they doing? And I mentioned 824 winter run coming back in 2011. We're working on an effort to try to figure out, and this is similar, not to the caliber and extent, but similar to the Lindley 2009 paper, what caused the fall run collapse. So we're putting an effort into trying to figure out what happened to winter run in 2011 that caused only 824 to come back. And I can't really speak to this, but I know that there's a technical memo on BDCP that's coming out that should be considered by the board. So some suggestions to the board to consider. I mentioned that the system as a whole and should be considered as that, starting with the reservoirs releases all the way down to any kind of standards that's imposed in the delta for outflow. There's alternatives I'm not sure the board's jurisdiction here, but there's alternatives to protect salmonids, including screening, non-screen diversions, different uses of water. Dr. Eric Danner mentioned this model where to meet 56 degrees at a certain temperature compliance point, do we have to release that amount of water? Can we release less colder water? So, in quotes, playing around with the system to see if we can do things better with what we have instead of just saying this is it and we can't change it. Increasing outflow in the San Joaquin. Brad mentioned the San Joaquin and the inflow to export ratio, and it's the same question. How can we manage better, but not on the backs of a listed species, using adaptive management? So if we think that it's flow that gets the fish out, instead of reducing exports, well, in addition to that maybe, how do we increase flows to get at the same metric that we're looking for? And all that I mentioned using the precautionary approach. One of the things that we're kind of struggling with right now as far as the joint stipulation and the Sentinel steelhead study is, does it make sense to do studies and adaptively manage, try experiments when there's listed species in the area? It might be okay for fall run. McCullum River was mentioned as one of the experiments, and that was done for fall run, I think. And that makes sense. Not to say that they're dispensable, but there's more fish in the system as opposed to, say, winter run. And this last one, we support the DCC gate objectives that Fish and Game mentioned. Not to speak for Fish and Game, but as far as including the DCC closure requirements from the 2009 biological opinion updated through D1641. So in conclusion, and this statement is similar to what Pat had. Adequate flows are essential. And we support the goals and biological objectives of the flow criteria reports. And I wanted to emphasize the goals and biological objectives. Just in summary, there are the 6 points which seem to be talking about habitat and water quantity and quality. Thank you.
Good morning, Chairman Hotman, and the rest of the board and the staff and everybody else between whose luncheon I am sitting. So I will try to be quick, but we have some stuff that I think is cool. So Aaron and I will be discussing the Environmental Protection Agency's take on today's topic. And we're going to actually give you recommendations. We're going to share some new analyses with you. Talk about what we might do for water quality objectives, talk about adaptive management, and again, make some recommendations overall. So starting with those recommendations, what we're going to say is look at the spring delta outflow conditions, and I'm going to give you background for this, but might as well throw them out there as well before we think about lunch anymore. That the spring delta outflow probably starts too late, and that it should be backed up to probably the first sign of storm events. I've been working on both the salmon and smelt management teams, and it's funny, come December or so, we both are waiting for the storms to happen, for the salmon to move out and for the smelt to move up. It's all queued on that first storm. So that seems like a good time to start the protective measures of delta outflow. There's been a lot of talk about how species might be in conflict with one another. At the last workshop, you heard a lot of stuff on that line. And I'd like to follow up on Garwin's comment that the whole system is connected. And one of the recommendations that EPA would suggest you model is removing that Roe Island trigger that is in the last water quality control plan. The intent of the Roe Island's compliance point was to ensure that the duration of a flow was historically comparable, because the durations of the flows when that was developed in the early 90s, were obviously getting shorter. And so it wasn't to force high flows, but to make sure that the storm duration was adequately long. And what you heard from some of your presentations that were given to you for the 2006 adoption of the plan showed that actually that had inspired greater holding back of some water, and that the trigger had been, apparently it looked like, manipulated so that that trigger wasn't pulled, and that one of the ways to do that is to hold more water back in the reservoir so that as soon as you can, you get the salinity moving upstream and not trigger that. that leads just to exactly the sort of dewatered reds that were described in Fish and Game's presentation. I really agree with Garwin that the whole system works together. There's been a whole focus on cold water pool versus outflow, but the cold water pool has to be released to achieve its goals, and it has to be achieved in a way that doesn't dry out reds, and that can be consistent with the requirements all the way down to Suisun Bay. Sorry. So that's part of operating reservoirs to maintain a cold water pool for salmonids, and in our coordinating meetings, I have to say we were quite united in saying that these are not a choice among species. It is, I'm sorry. It is management actions that need to be coordinated. There's been a lot of attention on fall delta outflow, and I'm going to address that more in the subsequent couple of slides. But in the biological opinion, it is key to year type, and it's a very on-off kind of switch. I think there's a lot of potential for keying that to more sensitive measures of whether it's appropriate or not, and to what degree. And finally, one of the things that has changed while that salmon decline has been going on in the San Joaquin is that the percentage between vernalis inflow and exports during the time when the adults are moving up has really gone from 3-to-1 exports to inflow to today it's about 8-to-1. A couple of weeks ago when they were moving up, starting to move up, it was more like 10-to-1. So how any San Joaquin River water ever finds the bay when adult salmon are trying to find vernalis is totally baffling to me. So both looking at spring and fall downstream flow connections so that at some point in both seasons there is river water flowing to the bay. One of the coolest things that has come out, you asked for what has come out since 2010, and one of the coolest ones is this historical ecology by Whipple and Grossinger et al. And I'd just like to draw your attention to the historical delta versus the modern delta. And one of the big things, let's make sure I have my notes here, is that it was a freshwater delta. Just to share some quotes with you, Whipple and Grossinger summarize all these as saying, while observations clearly suggest that brackish waters did at times extend upriver along Sherman Island under natural conditions, there's little evidence to suggest it regularly penetrated far into the delta. And they base that on people writing, as in 1772 in March, that at Antioch they found the water fresh and still, and again in Antioch in April of 1776 it was now very fresh, but we noted that it was changeable. And then again, Antioch in August, they camped without water, that of the river being still brackish. That was in August of 1841. And finally in 1879, after all these decades of experiencing it, the conclusion that they cite there is that the water along the San Joaquin frontage is fresh for 10 months out of 12, and in most years is fresh the entire year. Even in very dry seasons, it is fresh at low water. So the whole, I have not yet gotten all the way through it, but I recommend it highly. It's a very well done document and thought-provoking.
And that would suggest that there hasn't been any climate change in the last 140 years, I would assume?
I think we saw a lot of climate change. We've had little ice ages and everything else in there that have affected California's fisheries. So I'd like to just talk about X2 for a moment and refresh the board's perception of where various X2 correspond, where the low salinity zone's location corresponds with different X2. Particularly there, middle of Suisun Bay is about 65, and up in the confluence is about 85 to 90. And we showed you last time some results from three-dimensional modeling that can be done now that show kind of the spatial extent of that, so that when it's at 65, we have nice integration with all the remaining wetlands in the system of Suisun Marsh, the largest wetland remaining, and how that low salinity zone is integrated into that. Lots of shallow habitat, lots of areas where turbidity can come from. The Suisun Marsh is still filled with all kinds of food despite supporting clams. Whereas with an X2 of 85, the low salinity zone is up in deep river channels, not connected with wetlands really much at all, and in much deeper water and much less likely to be turbid or food rich. So there's real differences in just those 20 kilometers. And I'd like to thank Anke Müller-Zolger, who does more in a week than I do in 2 months at a time. And she just spun off a graph of X2 from unimpaired flows and thought that this was cool. And just a few things to pull out of this. Notice their seasonality. That if you look at unimpaired flows, not surprisingly, we live in California, it gets wets in the spring, and that means X2 is somewhere between 42 and 80. And in the fall, after the snow is all melted, X2 under unimpaired conditions is sitting there between 62 and 92. And if it's a dry year, then in both seasons, it's the low salinity zone is further west, and if it's a wet year, in both seasons, the low salinity zone is further east. So, and the box just captures that seasonal range from the unimpaired. So what happened after we took that historical ecology of the delta and channelized all of the river channels and removed all the wetlands and built levees and started having a lot of upstream consumptive use? What happened was that we were no longer in a fresh water in the eastern Suisun Bay most of the time, as described by the Allison Whipple and Robin Grossinger's work. But instead we saw huge spikes of salinity coming in dry years. 130, 140, tremendous. We see tremendous seasonality still. We see differences. The rainbow is still there, blue on the bottom and red on the top. But when you take away all those wetlands and you replace them with a lot of deep channels, then saltwater has a lot of place to come into. The tidal prism is huge. You get a lot of salt in. So thank the Lord, what we got were dams. So the dams, once they started operation, functioned like the wetlands. They held water back. They did a lot of returning that seasonality and moderating those salinity spikes that had come in when we changed the geometry. Notice that we still have the boxes from the unimpaired flow. This is actually historical data, but they're fitting within those boxes of the unimpaired. And I draw your attention to those black circles that are the monthly medians for all years, and how the blue ones are below them mostly, and the orange and light green ones are above them. But we're mostly filling the boxes. Then we started having exports, and this is, X2 of course relies on outflow, so the dams are still providing a seasonality of inflow. Inflow to the delta hadn't changed that much, but outflow had changed tremendously. And in dry and critical years, this is taking us up to 2000. They're pretty flatline. The seasonality is gone for the spring and fall. They're pretty much the same in those dry and critical years, and in the flood years, the blue lines are still down there. Fall variability is still what it was in the unimpaired condition, but there's a real gap there between the dry and critical years and the wetter years. The flood control in the spring versus water management conserving that in the spring, where we had those flat red and orange lines. And he clicks the button and nothing happens. So then, the board adopted the decision in adopted the Water Quality Control Plan in 1995. We started operating to it. And what happened was we got that seasonality back in the springtime. We saw, even in dry and critical years, we were seeing some lower X2 values in the spring months. It's fun there to notice the Jones track there. The calculated X2 says that we had a huge excursion of the low salinity zone upstream. Probably was not actual, but that's the way the data set reads. And then come fall, the bottom half of that graph is empty except for 2011. So that the blue lines are mixed up there with the orange and red lines, and fall in, it doesn't vary by year type. The springtime still does. That gap is still there between the really flood years And some of that gap in there may be the avoiding the roe island trigger that I mentioned earlier. But the springtime actually looks pretty good. We all addressed springtime conditions the last time the board developed a water quality control plan. And we focused a lot on restoring springtime range of conditions, and we seem to have succeeded. The cost we have paid for that is that we've lost the variability in the fall. And almost everything except 2011 is above the median. So just briefly looking over that, we had a freshwater estuary. We channelized it, levied it, took all the wetlands away, and we paid the price by saltwater intrusion. We had huge infrastructure investments, and we got rid of that saltwater intrusion. Then we really cut back on delta outflow as we developed exports, and then we started moderating that, and we protected one season, but we lost it in the other season. So I find this to be very neat and interesting, and now I'm going to pass it off to Erin.
Okay, thanks, Bruce. I'm going to go as quickly as I can through my slides because I know we are out of time and everyone is wanting to go to lunch. So I'm going to take the information that Bruce and others provided, and I'm going to talk about how we would recommend it be used in identifying ways to update the outflow objectives for phase 2 of the update to the water quality control plan. So a really straightforward thing to do is to identify a range of water quality objectives or water quality or alternatives to those water quality objectives that you might consider for each one of those objectives that is part of phase 2. So as you consider a range, some of them are going to perhaps provide less aquatic life protection and some will provide more. And we have quite a bit of information now about that range, and we could start to define it. So if you think of what is your no action alternative, that's the existing regulatory framework. And the existing regulatory framework is the 2006 Water Quality Control Plan flow objectives, plus the ESA biological opinions, and I'm including CDFG's incidental take permit in that. So that pretty much defines the current regulatory framework. That's kind of like the no action alternative. And we feel pretty confident about placing it at the less protection of aquatic life end of the spectrum because we have numerous documents out there right now saying that this is inadequate for protecting aquatic life beneficial uses. So then trying to fill out, maybe how can we inform some of the more protective alternatives we might evaluate for updating water quality objectives. We have the 2010 flows report from both CDFG and State Board, and some of the criteria in there may perhaps provide quite a bit more aquatic life beneficial use protection. Some of the criteria in there really are almost just the status quo because they took the reasonable and prudent alternatives from the biological opinions and put them in the criteria. So that's not so different than what we have now. But other of the criteria in there, I think, would perhaps provide quite a bit more beneficial use protection. So what we've tried to do on the next couple slides, really focusing on delta outflow, is try to identify some things to do that perhaps fall in between the 2010 flows report and the current status. Or I'm sorry, the current regulatory framework. And these are the things that Bruce quickly reviewed at the beginning of the alternatives, or at the beginning of the presentation. So for springtime delta outflow modifications, we're thinking of 3 things that it would be very interesting to evaluate as alternatives for updating the objective. So you could extend it into January or a reliable measure of the first storm. And this action is very well, I think, documented in both 2010 flows reports. Another thing you could do is eliminate the roe island trigger, but require the roe island standard. And this is in an effort to try and mimic the pattern of the natural hydrograph, so to improve the springtime standard. And then consistent with what Garwin was talking about earlier and what Bruce talked about earlier, treat the watershed like a whole watershed and figure out what you need to do to maintain the cold water pool and the reservoirs to support the functions that salmon need at the higher end of the watershed. So for fall delta outflow modifications, the things that we're recommending are to identify your range of X2 values that you might require as part of your objective using the flow criteria reports, but then also using some kind of reference condition. And we saw a nice reference condition in the charts that Bruce went through. I think it was the 78 to 99. The fall part showed a nice, I think, a distribution of a range of fall X2 values. So the next piece would be then how do you activate and quantify? So for how long are you going to require that condition in the fall? And in the 2010 flows reports, that's indexed to water year type. And we're hoping to do something maybe better than water year type to reflect really what water you have in the system. So some ideas for doing that are using the 8 river index. You could use the 3 previous months of April, May, and June, or you could use end of June storage. And this is one piece where we feel like you could also perhaps identify some experimental implementation as part of your adaptive management plan as you try to learn and move forward with updating the water quality control plan. Oops, it's not responding. Hold on. All right, so the last specific, I guess, recommendation we have at this point is to identify a San Joaquin migratory corridor connecting Vernalis to the bay. So we would recommend evaluating the spring pulse flows that are identified in the 2010 flows report. But for fall pulse flows, our recommendation is really to, I think, expand the range that you would evaluate. So right now in the 2010 flows report, the criteria is a 3-to-1 export to import ratio, and we think it would be very informative to look at a broader range, perhaps 1-to-1 to 3-to-1, as you look at alternatives for updating that objective. So a few quick words on adaptive management. We really feel like the triennial review is adaptive management built into the water quality control plan. And this is what I said the last time I was here in September. But if we chose to use that triennial review a little bit more assertively, we could identify right now what controlled experiments we want to do, perhaps the monitoring design to do them, and then most importantly, the support in terms of the dollars and water to do those experiments, and the data assessment afterward. So if we hope to increase our precision management of water in the estuary, then we really do need to provide the funding to do that monitoring and assessment. So this is a summary of what Bruce and I hope you heard us say today. So fish benefit from flows that mimic the natural hydrograph pattern. The 1995 Water Quality Control Plan objectives restored some of the springtime hydrograph pattern. Modifications to objectives should build on the success to improve habitat in all seasons, and we very much support using controlled experiments in the triennial review process to adapt. And I do have one last slide, and this is really just something I put together just for your convenience, and for each of the objectives that were identified in the January notice of preparation, we pretty much bulleted either what EPA said today, what we heard the other panel agencies say today, or what they've put in their written comments before, just as a place, or just as in an effort to consolidate it in one spot. And that's it.
Roger, are you just along for beauty today?
Yes, sir. I'm just here to answer any questions you might have about salmonids.
With that, thank you. You have a question? Go ahead.
This could be a help me understand it this moment. Our first panel did talk about, thank you for the presentations, for all your labors, particularly over the years, and particularly the focused attention that this period of time is taking on a lot of fronts, which I think makes me optimistic that something good will happen, because there's been more attention on these issues from multiple agencies and sources and entities than any time I can remember. The question I have, and maybe just that I missed something, is the last panel talked a bit about, that definitely talked about flow, because flow is important, but also talked about a number of other items that are important to fish's life, whether it's food or nutrients or predation or ocean conditions, or, you name them, regime change, which I know you know about and focus on, because Bruce, carries a picture of a quagga mussel in his wallet with him everywhere he goes. Sort of, you need to laminate that picture, because it's just going to get a little dog-eared, I think. But none of you really did, a little bit. Why? Is that something in our instructions that came out differently? Because it would be helpful to hear more of your thinking about, I'd relish hearing more of your thinking about the other aspects of the tools that we as a state can use, even if they're not directly in our quiver.
I took very seriously the board's questions because as I read them, they were about what should you do in regard to delta outflow. And these were billed as delta outflow workshops, so that was why I focused. But to expand it out into the other factors and how flow interacts with the other factors would certainly take us into October 3rd.
That,
But there is a lot out there. One of the things I would draw your attention to.
well, we may just need to have another conversation if it's in the question. That's why I'm asking the question, because not everybody read the questions the way you did.
Yeah.
So that's why I'm just a little confused.
Yeah, I admired the focus, and Brock was very clear in his invitations on the focus of recommend to the board what they should do about delta outflow. So that's what
So that's why.
that's what I was trying to do. There's certainly lots of other things to address out there, and there is actually the invited panel commented on how much work had been done on the impacts of exports, and that was because that was what was paid for. Now we're starting to get a mountain of data on other things that affect fish, and there's a lovely logarithmic growth in scientific papers published out of this estuary in the last 10 years because we have really started looking at lots of things. So that conversation could expand hugely.
I think that helps me understand the disconnect, and we'll just have to talk about it, what we do.
I'd like to add something if I can. So at the last workshop, I had one slide that was about EPA's action plan that we released
Yeah,
in
your action
August.
plan had a lot of stuff in it.
Pardon?
Yeah, you had a lot of different stuff in it.
Oh, okay, yeah. So in that action plan, we spend most of our time talking about actions that are really focused on contaminants. And we've said a lot of positive things about Regional Water Quality Control Board's efforts, both the San Francisco Bay and Central Valley, to really control contaminants. And they've taken many regulatory actions over the last 10, 15 years to really try and get a handle on organophosphate, pesticide contributions to aquatic life beneficial use impairment, and other of those more, I guess, water pollution, sort of chemical contaminant impairments to species. I mean, we noted that they are persistent and they're taking a long time to actually, take those streams off the 303D list of impaired water bodies, which is certainly our goal. And we're putting actually a lot of effort into assisting the regional boards with succeeding in achieving those load limits.
Thanks.
If I could just add to that, if you, excuse me, if you recall from Pat Brandis's presentation, that slide toward the end where she identified the multiple factors hypothesized for increased survival at higher flows. Well, the improved flows, flow is like the master variable, and so by improving flows, you improve water temperatures for salmonids, you lower the proportion of flow diverted. It helps those juvenile fish, particularly if you inundate floodplains, to avoid predation. That was mentioned by the expert panel, as well as improves, flows in the delta, such as Old and Middle River, to be more positive. And that increase in floodplain habitat has a number of benefits in terms of rearing for juvenile salmon, getting them bigger so that when they migrate downstream later, better chance of survival.
Right. There was some mention, but I was trying to understand the difference between the two panels in a way. So, maybe the experts just didn't listen to the question the same way, or they got a different question. But that's undoubtedly true, but actually doing things in concert with flow are going to make a difference. Where's your floodplain habitat? It doesn't just happen because you spread more water. So it's much more complicated and requires more action on more different parts. And I think the state of California and all the endangered species are going to be better served if we figure out how to do that in a coordinated way in addition to flow. So that's all I'm trying to get at. Not a critique. I was just curious and waiting to see. So you've helped me understand that distinction, and we'll just have to figure out what to do in another panel.
Stephen?
Oh, real quickly, thank you, actually. I appreciate the responsiveness to the board's questions and your presentations to everyone on this panel and the previous panel. And building on Felicia's questions, one of the factors, the stressors that we don't necessarily have a direct impact on as a state water board is the issue that's brought up a lot about predation in the delta. It's related to the homogeneous physical nature of the delta, but this panel has touched on ever so slightly, brushed against it quite just a little bit, about how the interaction between flow and predation. It was on one of Pat Brandis's slides that, generally speaking, a higher flow would lead to less predation. Could you build on that a little bit as far as the mechanism or the assumptions or any studies that have demonstrated a lower predation of salmonids or pelagic species that correlate with flow at different times?
Well, a couple studies come to mind. In the VAMP studies in 2011 versus 2010, I believe also 2009. One of the things that was noted, Mark Bowen put together some technical memorandums on the Head of Old River barrier study with the non-physical barrier. And one thing that he noted was that in 2009, the fish arrived that we released at Durham Ferry. They arrived at the Head of Old River very quickly, much more quickly. I think this has been talked a little bit about before also, that the migration to the Head of Old River was much quicker in 2010 than it had been in 2009. And with that, the mortality was decreased between Durham Ferry and the Head of Old River. What was interesting, though, in those Head of Old River barrier evaluations between 2009 and 2010, the predation that was identified at the barrier specifically still was between 23 and 27% in both of those years, indicating that predation was very high right there in the location of the barrier in both years, regardless of flow. So I think there's a variety of mechanisms depending upon where you are, what you're talking about. Structures, I think, are problematic. High flow, low flow years. There's certain areas in the delta that we've identified that have high predation outside the trash racks at the CVP. Clifton Court Forebay obviously is one that's been identified previously. One of the ones that we've identified in the acoustic tagging work that we've been doing is in the Stockton Deepwater Ship Channel. Why predation is higher there could be the fact that goes from a riverine really to the whole bathymetry in the Stockton Deepwater Ship Channel changes and potentially flows slow down, and so I think there's a variety of mechanisms, but I think that in general that at the higher flows will decrease predation. And I think in some of our previous submittals we've identified some of the links, turbidity increases in general as to have high flows, potentially site feeding predators are less able to find a fish, things like that. So we've identified some of those things in our previous submittals as well.
I'd like to add that I think it's not what we know now, but what we're going to learn in the future. There's several study designs to look at where we know predators sit with prey, but also to comment on both members' recent comments. If you look at Fish and Game's written comments, one of the issues that relates directly to predation is how dynamic is your river system and your floodplain. Where juvenile animals are able to move and to be is very limited right now, and it's not just in the main stem, it's in the delta. So you need much healthier, much more diverse riparian corridors and stream corridors. You need much